Okay, hi everyone. So I work at Cyber IT in Melbourne, and I work on a system that we've developed called PrisonPC. Now, PrisonPC is a server appliance that we've designed that allows inmates limited and monitored access to PCs and the internet. Its only relevance to this discussion is that it is based on another system we developed called Trim Client. Trim Client is basically you think of the concept of a thin client where you have a server that everything PXE boots off, and they run all their applications on the server via a remote display. Trim Client takes that a step further and runs all the apps locally on the desktop, so that you're making use of the commodity hardware that you've bought, and you're not hogging all the CPU on the server. This has several advantages, such as reducing server load, improving desktop performance because you're not pushing an entire display over the network, and it increases security because nobody's running nobody's got a shell on the server, they're all running everything locally. So Trim Client use cases in anything from correctional facilities to schools to offices, call centers, any environment that you've got centrally managed hosts, most likely homogeneous hosts that are going to be fairly similar with 3 or 4 different environments that you might have to deal with. So you might have a set of hosts that run media software, a set of hosts that run programming software, that kind of thing. Can I have a show of hands who here doesn't really understand how network booting works? Okay, we've got a couple. I'll skip through it. I'll skip through it really fast. So basically, you've got a desktop. It tries to boot off its network card, which has got a PXE-ROM on it. The PXE-ROM says, okay, well, I'm going to make a DHCP request. The DHCP server comes back and says, here is your IP address. Here is a TFTP server that you're going to pull down this config file, this boot file from, and it downloads and runs that boot file. In our case, we use PXE Linux, which is part of the SysLinux bootloader suite. And PXE Linux then says, okay, well, I need to pull down a boot file for this particular host. And it says, okay, I'm going to try a file name based on that host's GUID, which is the top one up there. And if it can't find that, then it'll try the host's MAC address, followed by its full IP address in hex, and it'll keep stripping off a nibble off that until it finds one that it likes. If it doesn't find any of those, then it'll fall back onto the default. So what we can do from that is that we can say, all these hosts, the config file for all these hosts are symlinked to this config file, which will boot this SOE. And the way we do that, and so once it's done that, it'll download the kernel on the RAM disk with the config line that says, use this root file system. We build SOEs using a piece of software that we wrote called Bootstrap. It's basically a shell script of about 200 lines. It's not quite finished yet because we haven't done all the configuration that we want to do, but it's not going to get much longer than that. It basically runs to Bootstrap. It says, okay, do a base install of Debian, and then we go and install the required packages that we care about. We install liveboot, which is Debian's liveboot solution. And liveboot basically does things like find and mount the root file system, which will usually be read-only. We share it over as a squashfs over NFS for the time being. We're looking at doing it over iSCSI, which we're hoping will be a little bit more efficient. It sets up a copy and write file system in memory so that you can make changes to it on the desktop without affecting the server. It'll pivot to that root file system, and then it does a whole bunch of other stuff that I'm not going to go into. But that's the main bit we care about. It grabs a network file system, unions it with a copy and write system, and it starts booting it. So what probably one of the more interesting parts of the way we do this is we've got this concept, this software called Trim Client Admin, which is another set of shell scripts. They keep 3 tables. There is a table of SOEs, which is just basically a list of here are the SOEs that we've got available for our desktops to boot. We've got a list of realms, and a realm is a logical grouping of machines that might be all in one lab, or they might be in cells, or they might be in a library, or whatever. And those those realms are all listed with the realm name and the PC name, or the IP address, or the MAC address, or whatever. And then we've got a table which lists all our hosts, and it's got the host's host name, the IP address, the MAC address, and the realm that host is assigned to. So you can say, all right, all these hosts in this classroom are assigned to the classroom realm. And then what you can do is you can say, all right, well, the classroom realm, it's 10 o'clock, the next class that's going to be on in this school is a programming class. Let's assign this realm the programming SOE, go, and then you reboot all the desktops, and they've all come up with that SOE, and you can change that trivially. The hardest part is actually going and rebooting the machines, which you can do over SSH if you want. And that's basically me done, actually. So just to summarize, it's designed for medium to large desktop deployments. It uses netboot to boot SOEs using bootstrap and liveboot. Hosts can be grouped into realms, and we basically create, basically all trim client admin does is it creates a config file for each realm, and it symlinks it into the TFTP directory for each MAC address of each host. So that all you're ever updating on a server is basically a whole bunch of symlinks. So you could write a trivial script that would do it without needing trim client admin. And then you just have to reboot the desktop to apply the configuration. Are there any questions? Yep.
What's kind of the age of the hardware you're typically dealing with?
The age of the hardware that we're dealing with, we've dealt with some fairly new hardware recently. I think it was probably awesome. We dealt with some hardware, it was probably about 12 months old now, and we are currently, we have been using Ubuntu Lucid, which is well and truly end of life now, but we're almost finished migrating to Debian Wheezy, which sufficiently supports the hardware that we've built, that we're getting from our vendor.
The reason for asking that was around your requirement of rebooting the hardware. You're looking at extending this around some of the out-of-bound management features a lot of modern hardware's got in the more desktop space. We're used to having out-of-bound management in the enterprise server environment. But now a lot of that desktop hardware has a lot of remote management capabilities. You don't necessarily need SSH. You can check that the hardware's alive.
Then do a remote reboot. Just trip the breaker remotely and reset.
Yeah, you could do that. We haven't investigated that option, but it's certainly something that we could try. Anything else?
Do you do anything to lock down the machines that they can't boot on USB?
Yeah, we've got, if anybody wants to talk about PrisonPC specifically, I can talk about it a lot later. I'll go briefly over it. Basically, we have a custom BIOS image that we got from the vendor, which basically doesn't allow any BIOS configuration. They'll boot from the network, and that's it. So they're sufficiently locked down, and the rest of it's all in software. Yep?
Are you aware of the Web Converger project?
No.
It's similar, but if you're not aware of it, I can't ask you how it compares.
No. I'll talk to you about it later, though. That'd be good. Anything else? Yep, up the back there.
Is this just in a class environment, or do they have a room where you actually use machines?
Sorry, can you repeat it? I wasn't.
Is this in a class environment?
So we haven't actually deployed this at schools yet, but we've deployed it at a couple of prisons.
No, in prisons where they
Oh, sorry. We have a couple of classrooms, I believe. We've got a few set up in a library, and we've got the inmates have actually got PCs in their cells as well. So that there will be different settings for each of those environments. Yep. We have investigated HTTP netbooting, and we determined that it's a bit ugly because HTTP netbooting involves range requests to the SquashFS, which is we weren't sure that we were happy with it. It is an option though. Liveboot will let you boot off a whole lot of different media, NFS, iSCSI, HTTP, and that's all just liveboot. That's part of Debian. So you can do that if you want, but we haven't gone there yet.
Are these Linux-only clients?
These are all only Linux clients. We haven't bothered to investigate anything else. Linux is what we're comfortable with locking down, is basically what it boils down to. Anything else? Yep.
So in your images, there's no persistent storage available to the users?
We do have some persistent storage available to users. They've each got a home directory available over NFS. We set pretty stringent quotas on them so that it's easy to go and search through contraband or whatever. But it is feasible. Anything else? Yep.
Have you looked at the Docker project?
Docker?
Yeah, Docker.
D-O-C-K-E-R?
Yep.
No, I don't know of it. I'll have a look it up though. Anything else? No? In that case, I'm done. Thank you.